So on page 654, you have the next big set of formulas. There's another 5 formulas that we're going to learn that are on your formula sheet. And just like the last big formulas, we're going to have them on our formula sheet and just get used to using them. So what we're going to do with these is say, hey, when I recognize I have either the left side or the right side, then I can change it from one to the other. And notice that there's 3 formulas for cos 2 theta and just one formula for both sine and tan. So when we have cos, right, because there's one here, and one here, if you have a cos 2 theta, you will have an option of which of the 3 to change to. And all 3 will work, but usually there will be one that's better than the others. So if you turn to example 1, and if you read example 1, it might start off sounding very familiar to other questions you've done, which is good, because we're going to use the same strategy that we would have done when we have questions like this in the past. Given angle theta is in standard position with its terminal arm in quadrant 4 and cos of theta equals 2/5. At that comma, your brain should say to yourself, hey, I've done questions like this before. I should probably draw a triangle in quadrant 4. That is correct. That's what we're going to do for this as well. But now we want to find sine of 2 theta and cos 2 theta. So the same thing that we've done in so many questions before, we're like, okay, I know it's in quadrant 4. I can draw it back to the nearest x-axis. I can label my reference angle. And I know that cos is 2/5, so adjacent over hypotenuse. A squared plus b squared equals c squared, and I would get the square root of 21. And from this, we already knew that cos of theta was 2/5, but now we know that sine of theta is negative root 21 over 5. In part A, we're asked to find sine of 2 theta. Once again, the only thing you're going to be able to do with these 2's inside of sine is to use one of your formulas. So we have the formula. The formula says that sine of 2 theta is equal to 2 sine theta cos theta. And then, just like before, you do not know what theta is, but you do know what all of sine theta is and what all of cos theta is. So we can replace all of sine theta with root 21 over 5, all of cos theta with 2 over 5. And if we multiply this out, this 2 would be 2 over 1. How do we multiply fractions? Multiply the tops, multiply the bottoms. The bottoms will be 25. Tops will be negative 4 root 21 over 25. Okay? What you're going to be tempted to do, which you're not allowed to do with these ones, is students are sometimes tempted just to say, well, if sine theta is this, can I just multiply this by 2 to get sine 2 theta? No. The only thing you're going to be able to do is to use your formula. Now in part B, they ask for cos 2 theta, and we have 3 formulas. And in this question, I would say all 3 formulas are very close to being identical and equal, but I would say there is one that has a slight advantage over the other ones. And the one that I would, well, you can look at all 3 and see if you could take a look at all 3 and decide which of the 3 would you like to use. And then I'll tell you the one that has a slight advantage and see if you pick the right 1 for the slight advantage. Again, in this question, it really is so minor a difference that it wouldn't really matter. But the one that would have the most advantage in this one would be to the one that has only cos. And the reason for that is because we had to figure out sine. And there's always a chance when you figure out something that you make a mistake. But we never had to figure out cos. It was given to us in the question. So that's why this one has a slight advantage. We didn't make a mistake with sine, so it wouldn't have made a difference. But now, so the only thing you can do with the cos 2 theta is change it to one of the formulas. Since we know that cos of theta is 2/5, cos squared of theta would be 2/5 squared. Order of operations, you would square first. Then this 2 is 2 over 1, so how do I multiply fractions? Multiply the tops, multiply the bottoms. How do I subtract fractions? I need a common denominator, so I'll change that 1 to 25 over 25. Which will leave me with negative 17 over 25. I'd like you to circle question number 9.